Okay. Hello. Our topic for today is simple curve sample problem. So this is not the usual simple curve problem. This is more of how are you going to field location determination of the uh, points or stations in a simple curve. So this is a problem. So the intersection angle of a 4-degree curve is 55 degrees and 25 minutes. And PC is located at station 238 plus 44.75. Determine the length of the curve determine the station PT. So we have determine the length of the curve, determine the station PT, determine the deflection angles and chord lengths for setting of curve and full stations from the point of curvature or the PC. So to lay it out, it's just a very simple problem actually. So the intersection angle of a curve, so we are going to draw a curve. So for example, you have a curve like that and you have this, okay? So then the intersection angle, so oh no, hindi siya tumama. Okay, so that's it. The intersection angle is what? Let's use color violet. The intersection angle is 55 and degrees and 25 minutes. So this is 55 degrees and 25 minutes. Let's turn off the style. So this 55 degrees and 25 minutes, meaning to say if this is 55 degrees and 25 minutes, this should be also a 55 degrees and 25 minutes as well. Okay, then intersection angle of a 4-degree curve. When you say 4-degree curve, meaning to say if you have a curve like this one, oh no, okay, so your deflection angle is 4 degrees, so meaning to say this one is 4 degrees, and the standard distance is per station of a curve is 100 feet. So that's a simple analysis of that. Then one more thing is, let's make it thicker. The PC, and this is PT. The PC is stationed at 238 plus 44.75 feet. So this is, let's use violet. So station at 238 plus 44.75 feet. So the question is determine the length of the curve station at PT. So first question is let's say the first question is number 1, length of the curve. So question number 1 is asking this one. So what's the length of the curve? How long is the arc? What's the length of the arc? So it's very simple to determine. If you have this, right, it's a chord basis style. If this is a 4 degree and this is 100 feet and this is R, so first you solve for the radius. So what's the radius of the curve? Using chord basis. Okay, so given that situation, if you have this 4 degrees, you have the R and you have the 100 feet, so you just need to follow the standard formula for getting the length of the arc. S, which is the length of the arc, R is the radius, and theta is the angle between these two lines. Okay, so you have S is equals to R theta, and S will be 100 feet. R is undefined, or R is missing, or R is unknown, and you have a degree of a curve of 4 degrees, but you need to convert 4 degrees into radian before you multiply it by the R. So to do this, you have the 100 feet is equal to R. Convert the 4 degree to radian, so that's pi all over 180 degrees. So cancel degrees. So R will be 100 feet all over 4 times pi all over 180. Then R will be, in terms of feet, is let's compute. So that's 100 all over 4 pi all over 180. So that's 1432.39 feet. So in meters, that's 1432.39 divided by 3.28. So that's around this is in feet, so in meters that's around 436.70 meters. So this is the value of the R, but actually the problem is asking for the length of the curve. So given the value of the R, let's look at the bigger scale, since this one is 55 degrees and 25 minutes. So you already have the value of the R. So if you will draw it something like this one, you already have the value of the R, which is 1432.39 feet, and you have the angle between these two lines, which is within these two radii, which is 55 degrees and 25 minutes. So you have the missing length of the curve. So this is unknown, or is equals to length of the curve. So let's follow the formula again. So S is equals to R theta. S is missing. R is equal to 1432.39 feet times theta, which is 55 degrees 25 minutes, converted to radian, pi all over 180 degrees. So the length of the arc, or the L, is equal to it's 1432.39 times 55 degrees and 25 minutes times shift pi all over 180. So the value of the length of the curve is, if you'll compute it, is 1385.42. So meaning to say, you have this length. So given that situation, the length of the curve will be 1385.42 feet. Okay, so the first question is already solved. So your value of length of the curve, or S, is equal to 1385.42 feet. Okay, so your first question is solved. So 1385.42 feet. Then next is determine the station PT. Okay, so how are you going to determine the station PT? Okay, if you already have this situation, if you have this curve and you have this deflection, and you already have this, let's just extend this one, and you already have this and you already have this PC, and you have this PT. So if this is a station, what do you call this station is? Station is PC 238 plus 44.75. Okay, 238 plus 44.75. All you have to do is just to add this 1,385 feet. So actually, that's what is stationed at PT. Okay, so all you have to do is just start from here and add the length of the curve, which is 1385.42 feet. But unfortunately, you need to like check this one. So okay, station PC is at 238 plus 44.75, right? So the length of the curve, or L, is equal to 1385.42 feet. Okay, so in order for the PC to say point A, to become 239 plus 000, so it has to be, the 44.75 must be deducted by 44.75. So 100 minus 44.75 is 55.25 feet, meaning to say 55.25 feet will be deducted from 1385. So 1385.42 minus 55.25. So 1385.42 minus 55.85, sorry, 25. So the remaining will be 1330.70. Okay, so how many stations there are? The length of the remaining length of the curve is 1330.17. So meaning to say 1330.17 divided by 100 feet, that is the distance per station. Which is, okay, so that's how much? 13. Okay, so 13 stations at length of 100 feet. So meaning to say 239 plus they call this 239, this one, add 13 stations, will be 239 plus 13, that will be 252. So meaning to say 252 plus 00, then you have remaining this is the new station, but you have an excess of 30.17 because you only get 13 stations, which is at 100 per station. So 1330.17 minus 1300, so it's 30.17. so your station will be 252 plus 30.17 at station T. Okay, just to lessen the complication of our thinking, so all you have to do is to do this. So you have station at PC is equal to 238 plus 44.75. The length of the curve is 1385.42, meaning to say that's how many stations this for divide 100 feet, so that will be 13 stations. You have an excess of 85.42. so this is excess. Okay, so the excess station, so all you have to do is 13 is 100 and excess of 85.42, so you just need to add 13 plus 85.42. so this will be what's this, 251 plus 44.75 plus 85.42. so this one is 130.17. so there's no 130 because the the maximum is 100 feet, so you add this 100 to here, so this is one station, right? So one station will be 251 plus one station, which is 100 feet, plus 30.17, which is the remaining station, so that will be 252 plus 30.17. so this is the station PT. So I hope it's clarified. It's either you do this or you do this, so it's up to you. Okay. Okay, so meaning to say, your station at PT is at 252 plus 30.17. So that's your station PT. So we're able to solve this. So this is station at PT is 252 plus 30.17. Next questions: deflection angles and chord lengths for setting of the curve at whole stations from PC. So that will be our next problem. So let's redraw. Say a big. Okay, if we will lay out, if we will put everything into layout, so you have 13 stations here, right? Something like that. 13 stations. Then this will be, what do you call this? This is station is this one. This one is 238. This is PC at 238 plus 44.75. The next station will be 239, right? Plus 000. And this one will be 252 plus 000. And this station is at sorry, pesos na. This is station PT at 252 plus 30.17. Okay, so if you will connect this line going here, okay, and going here, okay, so this is the, okay, so meaning to say, if this is 239 plus 00 and 238 plus 4.75, the distance between this two station is what? So we discussed earlier, this is 55.25 feet, and this one is 30.17 minus 000. It's what they call this, 30.17. Okay, so if we will put everything into layout, so how are we going to solve for this one? Because these 13 stations, if you have 13 stations like this one, you know that the distances between each station is 100 feet, and the deflection angle of that is around 4 degrees, right? 4 degrees. And you have a radius of what? I forgot the radius. 1432.39. Okay, in this situation, you have like a relationship. So if this is S, so this one will be your relationship. Here, hello. Okay, so let's say this is the length of the curve. Okay, so this is the length of the curve, and this is your delta, which is the deflection angle of the entire length of the curve. And you have this, let's say color red, okay, and you have this mini, let's say this is mini L, or this one, and this one is, let's say this is gamma 1. So by formulating a relationship, we will have a relationship like this one. So if gamma 1 is equal to small l, so being to say delta will be L. So this is the relationship that we can formulate, or we can say that gamma 1 all over delta is equal to small l or l. So you can use this formula as reference. So with this one, we will be able to solve for the value of the gamma 1, which is located here, and this one is the gamma 2. So these are the unknown deflection angles. Okay, so as we tackled before, so if this is gamma 1, the angle between let's use other color like yellow. Sorry. If you'll have, what's this, tangent? Okay, you have tangent here. Okay, so if you'll remember on the last topic that I discussed to you, if this is gamma 1, the angle between the first station, the line connecting the PC and the first station is half of the gamma 1, right? Okay. On the next viewpoint, if you will connect this PC to that next station that you have, the angle between will be gamma 1 plus 4 degrees all over 2. So if you'll just be in reference on the past topic that I've discussed to you, so that is rules that we are following here. Okay, so meaning to say, these are the deflection angles starting from the PC. This one is the deflection angles. This is also a deflection angle from the intersection of the radius, okay, of the radii. Okay, so this one is the deflection angle between the intersection of the chords connecting the PC to the other station and the tangent one. So this one is the tangent one. So with that, we can determine the value of the gamma 1 using this relationship. Okay, so using this relationship, if you will substitute it here, like gamma 1 is to delta. What is delta? Delta is the total, right? Is equal to small l, which is the length of the small chord here. Length of the small curve and the length of the total curve. So we have gamma 1. What is gamma 1? We don't have gamma 1. And we have the delta of 55 degrees and what's this? 25 minutes, if I can recall correctly. Yeah, 25 minutes is equal to, what's the smallest value of L? What's the value of L? So this one is the 55. Sorry. 55.25. So if you can recall how did we do, or how did we get this 55.25, so you can just recall your video, so just for you to see. So this one is I guess it's 55.25. Yeah, if I can recall correctly, 55.25. You might be confused. This is 55 degrees and 25 minutes. This is 55 and 25 feet. What's the length of the chord? So we're able to determine the length of the chord, which is 1385.42 feet. Okay, by ratio and proportion, what is the value of our gamma 1? The value of our gamma 1 is 2.21 degrees. Okay, so the value of our gamma 1 is 2.21 degrees. So meaning to say, if this is 2.21 degrees, what is this one? So this one is if gamma is 2.21 degrees, right? So your gamma 1 or over 2 is equal to what? Sorry, 2.21 divide 2. So that's 1.105 degrees, or 1 degree 6 minutes and 18 seconds, because this is only half of this deflection angle. This one, this one is half of this deflection angle. Okay, so if this is gamma 1, 2.21, the half of deflection angle will be gamma 1 all over 2, which is 1.105, or 1 degree 6 minutes and 18 seconds. So with that relationship, it will be easy for us to determine the stations, the deflection angles between the tangent one and the chords that you are making, and the chord length. Okay, the chord length. So let's check it. Okay, so we have the station. Let's view this paper. Let's try larger one. Yeah. So let's draw. If you have station, you have the deflection angle, and you have the chord length. Okay. Okay, so how are you going to get the deflection angle? This is the gamma 1 all over 2, or d all over 2, or gamma 2 all over 2. So the chord length, so it's basic. Okay, sorry. This chord length is the station A and the station B. So instead of using arc, you can use chord using a chord basis. So because the problem is asking for the chord length, not the arc length, you divide it. What's the value of this? D, right? The half will be d all over 2, which is the deflection angle between two radii. So this is r, which is the same. Okay, so what's this? If this is the chord length, the chord length, say all over 2, let's say CL, or chord length, and the total will be the chord length. Okay, so how are you going to use to solve for this? This one will be sine theta. So let's try this. So you have the sine theta, which is opposite. This is chord length, right? All over 2. Adjacent, which is hypotenuse, which is opposite all over hypotenuse, which is the r. So meaning to say, if you have the sine theta available here, so you can determine it, then you can solve for the value of the chord length. So you have the sine theta times r is equals to chord length all over 2. So chord length will be 2 sine theta times r. Okay, so this will be your governing formula to solve for the chord length. Okay, so let's solve that. So you have station what? PC. $252 then 252 plus 30.17. What is our deflection angle? Deflection angle will be from the very start, that should be 0, right? 239 plus 00, so that's from PC to this one. So from PC to this 239, So that is gamma 1 all over 2, which is value of our gamma 1 all over 2, which is this one, right? So 1 degree, 6 minutes, 6 minutes and 18 seconds. So you add 2 degrees because the deflection angle is equal to 4. Deflection angle of the curve is equals to 4. So that's always d all over 2. So that's starting from PC to this station, which is 240, station 240. So that will be gamma 1 plus 4 all over 2. So what's the gamma 1 plus 4 all over 2? So that is side calculation, that will be 6 minutes 8 seconds plus 2 degrees will be 3 seconds 3 degrees, 6 minutes and 8 seconds. So plus 2, that will be 5 minutes 5 seconds, 6 minutes and 8 seconds. 5 degrees, 6 minutes and 8 seconds. You have the 7 degrees, 6 minutes and 8 seconds. You have the 9 degrees. Guys, I'm really sorry, that must be 18 seconds, not 8 seconds. I'll correct in the next minutes of this video. Thank you very much. That must be 18 seconds, not 8 seconds. Thank you. Plus 2 is 27 degrees, 6 minutes and 8 seconds. Okay, so what's the remaining one here? So how are we going to solve for the 30? That's very simple. We can do the ratio and proportion. Let's solve it by using the ratio and proportion. We have the gamma 1 all over delta, so is equal to also to, so gamma 2 all over delta is equal to L1 all over, what's this, L, or L2 all over L. So we can use that relationship. Let's try it. So you have gamma 2 all over 55 degrees and 25 minutes is equal to L2, which is 30.17 all over, what's the length of the curve, 1385.42. What's your value of gamma 2? So you have 55 degrees and 25 minutes times 30.17 divided by 1385.42. Mali ah. Sorry. Paano nila sinolve yun? So nagkakahin 55.416 all over 2. Ano ko nahin 55.416? Tama naman. Wait lang. solve for relationship L2 all over gamma. Sorry. Solve for relationship. This is for example L2 all over L is equal to gamma 2 all over delta. Okay, so you have what's your L2? 30.17. What's your L? Your L is 1385.42 is equal to gamma 2 all over 55.4167. So your gamma 2 will be 1 degrees 12 minutes and 24.47 this second. So gamma 2 all over 2 will be 36 minutes and 12.23 seconds. 36 minutes and 12.23 seconds. So meaning to say your gamma all over 2 is the value of deflection angle at station 252 plus 330.17 is 27 degrees 6 minutes and 8 what do you call this seconds plus 0 degrees 36 minutes. Okay, let's say 12 seconds. Okay, or 12.23 seconds. So this will be 27 degrees 6 plus 36 42. Adding that must be 27 degrees 42 minutes and should be 30.23 seconds. Okay, 30.23 seconds. It must be close to half of checking. It must be close to half of 55 degrees and 25 minutes divided by 2 is let's say 27 degrees and let's say 42 minutes and 30 seconds, which is actually close. So maybe there are some minor errors that we encountered. So just to justify that is this relationship that I am telling you a while ago. So we have right, so if you'll connect PC to PT, okay, so if this is 55 degrees and 25 minutes, this one, the chord connecting these two, this one must be 55 degrees and 25 minutes all over 2, right? Must be half. So the deflection angle of the last station must be half of this, which is correct naman, which is correct. So it falls close to, okay, there are just some like few errors, but it's close. Okay, so what are the chord length of this? So considering the chord length, this must be 0, right? This must be 0. What's the chord length of this? So given this formula, so let's say 2 sine 1 degree is 6 minutes and 8 seconds times what's R? R is, what's the value of R? R is 1432.39. So what's the value? 25. Sorry guys, it must be 18. All must be 18. Sorry for the confusion. So all 18 because this is 18. I missed it. Sorry. Yeah, 18. sorry, that should be 18. That will be 55.25. Okay, the chord length of the next will be 2 sine. Okay, what's the deflection angle of this? The chord to chord, so let's say station 239 plus 240. So what's this? So what's the deflection angle? So that's 4, so we need to say the half of that, right? So no, sorry, yeah, the half of that. So that's 2 degrees times 1432.39. So what's this? 2 degrees. So this is 99.98. Since all of this has the same, so this is 2 degrees as well, 2 degrees as well, starting from 241 to 242, 242 to 243, so 2 degrees, 2 degrees. So I assume this, all of this has the same value, which is 99.98 feet, which is close to 100 feet. So the last one will be having a chord length of 30.17, which is, we reiterated it actually here. So meaning to say, we were able to determine the deflection angles of the different stations and the chord length of the different stations. So if we will just put it into layout, so you have, how many stations are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So there are 15 spaces. So if you will be having, actually it's too big, I don't know how am I going to this to solve this. If you have, this is 15, so you have 1 2 3 4 5 6 7 8 9 10 11 12, sorry, it's going down. 1 2 3 4 5 6 7 8 9 10 11 9 10 11 12 13 14 15. Say 1 2 3 4 6 7 8 9 10 11 12 13 14 15. So there's an excess of 1. So mean to say, if you will, actually this is very steep one, so just exaggerate it. Just exaggerated it. Let's connect all of the lines. So considering all of the points are like stations, so you have a, sorry if kinda too much curve on it, so you have PC, oh it's so small, use thicker line. If you have PC here, you have the 249, you have the 250, sorry, that's 239, sorry. If you have the PC here, you have the 239 here station, 240 station, 241 station, 242, 243, 244, 245, 246, 247, 248, 249, 250, 251, 252, 252 plus 30.17, or the PT. So meaning to say, if you will put it into layout, you have a radius of this have this radius. Okay, you have this radius, and you have this radius connecting different vertices to the intersection of the radius. It must be equally distributed, I'm sorry. Okay, so on and so forth. So on and so forth. So it will all intersect here. So sorry for the confusion. So it will just connect on these intersections. So meaning to say you have the gamma 1 here, the gamma 2 here, which has the volume of, which is the value of, which is the value of gamma 1. You have this one. This one is the value of the gamma 1. Is it the value of gamma 1? Yeah, the value of the gamma 1. And you have the value of the gamma 2, which is the value of the gamma 2. We solved it already. Okay, so the value of this are 4 degrees, right? Because this is the deflection angle, so all of these are 4 degrees. Until here, 4 degrees. The value of this is the gamma 1, and this one is the value of the gamma 2. So this one is gamma 2 all over 2, so the gamma 2 is this one, 1 degrees. And so that's it. Deflection angles, if you will connect PC to PT, you have the different deflection angles, right? Those are the deflection angles. Sorry, the chord connecting. Okay, so if you will understand which is the 55.28, so these are the 55.28 distances. 55.25, sorry, 55.25. These are the 55.25. This is the 99.98 hanggang dito. Yan, these are 99.98 typical dimensions per station. So these are the deflection angles, deflection chords. So these are how the locators are doing it. Kinda messy, but this is how they do it on site. Okay, so here is 30.17. So that's it. Yeah, that's it. I hope you learned something from my topic, and yeah, it's kind of, I don't know if it's complicated, but I guess this is a very easy topic. So I hope you understand this one. And to solve the questions here, you have the value of the length of the curve. You also determine the station at PT. You're able to determine the deflection angles. You're able to determine the chord lengths at different stations. So I guess that's the end of our lesson with simple curve. I hope you learned something. So if you have more questions, you can comment down below, or you can send me a PM here at our channel. So I hope you learned something. So thank you very much.